Hey guys, Coach Sharp back here. Welcome back to my videos of our work while we are away from school because of the virus. So today I'm going to start my videos starting on what's at least going to be our work for weeks 3 through 5. Hopefully we are back at school after that point. We'll see. But I sent out the 200-page document to everybody. It's on Canvas as well. It's also on the school's EOC website. So all y'all gotta do is one page at a time. And again, this week we're starting Monday through Thursday. So I'm posting this Tuesday night, March 31st. Y'all should have done this first page yesterday, done the second page today. Again, I'm posting it a day behind to give y'all a little time to do it, just to finish up. So with that said, let's jump into it. All right, problem number 1. What are the center and radius of the circle whose equation is x minus 5 squared plus y plus 3 squared equals 16? Again, we've seen a few of these now in our work. This is the equation of a circle. And again, we were going to get to this. I was actually going to skip it and go into statistics, which we really haven't even seen a lot of right now. And come back to this at some point, but we've kind of seen it, like I said, a few times now. So this is the standard equation of a circle that would be drawn on a coordinate plane. The h and k represent the coordinates of the center. The h is the x coordinate, the k is the y coordinate. And since they are both being subtracted in the formula, whatever number is there, we got to take the opposite sign of, because again, the negative when it's in a formula means I need the opposite of whatever number's there. So if I had x minus 3, my x coordinate would really be positive 3. If I had x plus 3, my x coordinate would really be negative 3. Same with that. And then over here on the equal sign, that is the radius squared. It's not the radius, it's the radius squared. So if we apply it here, I've got x minus 5. So I really want the opposite of that, which is positive 5. X plus 3, I want the opposite of that, which is negative 3. So that would give me 5, negative 3. So again, we can go ahead and eliminate answer choices. They have them as 1 through 4 instead of A through D. But we can eliminate 1 and 3, so we're down to 2 and 4. And again, now the question is our radius 16 or is our radius 4? If we come back to our formula, the number on the other side of the equal sign is the radius squared. So again, if you want to write it, finger got in the way. Sorry. Let me take my top off. This is going to take a sec. Top off my marker. All right. So I know the radius squared is equal to 16. Again, hopefully everybody should know what the radius actually is, but if you want to do algebraically, square root both sides, the radius is 4. So it's going to be the fourth answer choice there. Again, if y'all want to put D instead of 4, that's fine. But it is 5, negative 3 is the center, and 4 is the radius. All right, number 2. Number of degrees in the sum of the interior angles of a pentagon is 72, 360, 540, 720. Again, we talked about this a little bit during the year, even though y'all didn't realize it, and we saw it on one of the earlier practice tests. I think actually was the pentagon as well. So if y'all think about it, you know the number of degrees in a triangle is 180, number of degrees in a quadrilateral is 360. What actually happens is every additional angle you add to a shape, the number of total degrees of the angles inside, so you measure the angles as they open up inside the shape, is increased by 180. There is a formula for that, which is n minus 2 times 180. So this is going to give us the total number of degrees of the interior angles. We also looked at it where you can get the number of degrees of a single angle by dividing that by n, but again, that's not what we're looking for right now. So n is I'm going to put the number of angles, but of course it's also the number of sides. We have a pentagon, which is 5. So 5 minus 2 times 180. 5 minus 2 is 3 times 180, which is 540, which is answer choice 3. Or again, if you would like to put C, that is okay as well. So that is number 2. All right, let's see here. I can get that down. All right, number 3. The coordinates of the endpoints of line segment AB are 0, 0, and 0, 6. The equation of the perpendicular bisector of line segment AB is blank. So this is one of those problems where, again, we didn't necessarily learn this, but if you kind of break it down to things that we have learned, hopefully it'll make it easier. It tells you the coordinates of line segment AB. So I'll go ahead and draw a coordinate plane and plot them. All right, so got my coordinate plane drawn. A is at 0, 0, and B is at 0, 6. So I'm going to go 1, 2, 3, 4, 5, 6. Go up a little higher. Okay, so there's B, there's A. All right, and I'm going to bold this a little bit to show that that is our line segment. Equation of the perpendicular bisector. So, again, those don't look like equations, but those are equations for lines that we would draw on the coordinate plane. For example, x equals 0. Every point on that line, the x coordinate is 0. So 0, 0, 0, 1, 0, 2, so on, so on, so on. So let's think about the perpendicular bisector. It's a line that would cut AB into 2 halves because it bisects it. So it cuts into 2 equal halves. Let me rephrase that, 2 equal halves. And is perpendicular. So we look at what we drew. Again, I know it's a little crooked looking, but this line would be going straight up and down. So to be perpendicular, I need to be going across. Okay? And so I also want both parts of the line to be equal. So I need to go halfway in between. So I went y to 0, y to 6. So halfway in between, of course, is going to be 3. All right? So this is where my line would cross. And it would go straight across as so. So what would be the equation for this line? Well, we kind of map it out. This is 0, 3. This is 1, 3. This is 2, 3, 3, 3, 4, 3, so on. What they all have in common is the y coordinate is 3. So it would be the line y equals 3, which is answer choice 4. Or again, if you just want to put D, that's okay. All right. Number 4. Again, something we've seen in our work a couple times that we've been doing, although something, again, we didn't necessarily explicitly talk about during class. In scaling triangle ABC, so again, let's kind of review as we go. Scaling, we know none of the angles are going to be the same, right? Measure of angle B is 45 degrees, and the measure of angle C is 55 degrees. So I'm just going to draw a triangle. All right, here's my triangle. Put A up there, B up here, C over here. It tells me B it says 45. That should be 45 degrees. So 45 degrees. It says C is 55 degrees. So what do I know about triangles? All the angles got to add up to 180. So that's going to, 55 and 45 is 100. So I know A has to be 80. So it says, what are the order of the sides in length from longest to shortest? So again, what we got to remember is, we've learned this before, the longest side is going to be across from the widest angle. Because again, I've showed this a couple different times in class this year. Again, you got to think about it. I'm going to try to show it with my fingers so y'all can see. All right, if I had a angle, so the angle is I can't really point at it, but the where my fingers kind of meet down here at the bottom, okay? If that's the angle, if this isn't that big of an angle, the distance between my two fingertips isn't that big, right? But if we make the angle bigger, if we make it wider, the distance between my fingertips got longer, right? So it's this, it's the same idea within triangles. That's where we get it from. So the side across from my 80-degree angle is going to be the longest side. 55 is going to be my medium side, and across from 45 is going to be my short side. So the long side is, we have it as CB, but it can be CB or BC. The middle one is AB or BA, whatever the order would be, and the long one AC or CA. So we want longest to shortest. So let's see here, we want BC or CB first. That's going to be the key. So 2 and 4 both have BC first. So we're down to those. Next was AB. Again, could be written as BA as well, but all of them have it on AB. So AB was next, which is answer choice 4, and then AC is last. Okay? So it's going to be answer choice 4, or again, letter D if you're doing it by letter. So 3 out of the first 4 have been D. Or answer choice 4, however you want to say it. All right. Number 5, parallel lines with the two transversals, actually. Again, one of my favorite things, I think one of the easiest things we do in geometry. So, in the diagram below, lines N and M are cut by transversals P and Q. What value of X would make lines N and M parallel? So there's actually a couple different ways that you could go about this, okay? So let me draw this diagram again. Might have to put down the phone for a minute because it's kind of hard to keep this whiteboard from moving. Now give me just a second. And M, there's P. Here's Q. This is going to look a little off center, but that's fine. All right, that's 30. This is 80. There's X. All right. So, here we go. All right, we got to get X. So, there's a couple kind of different ways you could go about it, okay? You could say, well, I've got a triangle right here, right? So if I can somehow figure out those two angles, I can then figure out what this is to add up to 180. The other thing you can say going back to the parallel lines of the transversals, if we ignored this transversal for a second, the kind of more diagonal one, and I go this one, okay, you could say that, well, let me use my parallel lines with transversals relationship. So I know this would be, if you kind of drew it over here separate on the side like I'm doing here, okay? Again, I know that's not straight. Y'all deal with it. All right, here's X. So you say, okay, it's going to be congruent. No Siri. Siri popped up. I don't know why. It's going to be congruent to that one because of opposite interior. It's going to be supplementary to this one because the same side interior. It'd be congruent to that one because they are corresponding. It'd be congruent to that one because they're vertical. Supplementary to those because they're a linear pair. Well, let's look at what information we have, okay? We got the extra line that goes across it. So we're saying that I know this is 80 and I know this is 30. So you say, okay, well, I know part of this whole angle is 30 and I know part of that whole angle is 80. So you can really do either one, okay? The other thing you have with that transversal and the one that came down, so I'm going to draw those kind of separate. Those are just my two transversals, okay? You've got right, that's 80. And so then you would know that this has to be 100, that has to be 80, that has to be 100, okay? So this angle, I know it's kind of tucked in here, has to be 80, okay? The other thing you could kind of say is, if you weren't looking at this transversal, if you were looking at this one and this parallel line, again, trying to draw it like that, and there's 30. Because of vertical angles, that would have to be 30, which is the key. So you could also say that that angle is 30. Okay? So, actually, you don't really need these up here because this one doesn't actually have, I was thinking this one doesn't really have a relationship with that one. All right, so, well, let's kind of get back in now. Again, there's kind of two things we do here. We could say this is 110, and again, this whole angle and this one are same side interior for that transversal. Okay, or the other thing you could say is, again, with the parallel lines with the transversal, this one coming down, this is 30. This one would be alternate interior to that 30, so that's 30. So you've got that being 80 and 30. And then you've got this third angle, so you've got 80 and 30, add up to 110. This whole angle, and that would be supplementary, so they got to add up to 180. This is 80 and 30, which is 110. And all three angles of the triangle have to add up to 180, but either way, you're going to get that x is 70 degrees, which is 3. So answer choice C. So we've gotten 3 D's and 2 C's so far. Or 3 4s and 2 3s. All right. I asked one on the first page. In a diagram below, LATE, hold on, let me erase this. Give me a sec. All right. LATE is an isosceles trapezoid where line segment LE is congruent to line segment AT. LA equals 24, ET equals 40, and AT equals 10. Altitudes LF and AG are drawn. What is the length of LF? So, again, trapezoids we didn't really cover, but you pretty much have all the information you need here. Okay, so let me draw this out again. I'm going to have to put my phone down for a sec. Here, I'll do the kickstand so you're not seeing black for a second. It's just the corner of my laptop, which probably isn't much more help, but not the best trapezoid I've drawn. We'll just roll with it. LFE A G T 10 24. This whole thing is 40. All right. So, what do we know? All right, line segment LE is congruent to line segment AT. All right, so we got LE, I know the lights are reflecting, congruent to AT. So since that's 10, that's 10. Okay? Everything else we already have. Altitudes LF and AG are drawn. What's important about those being altitudes? Again, they're going straight down. Okay? So essentially, we formed a rectangle and 2 right triangles. Okay? Rectangle and 2 right triangles. So I know this is 24. Okay? And again, since we're doing it straight down, and those are the same, it's isosceles trapezoid, our assumption is that GT and EF are equal. Okay? So the whole thing is 40. This part's 24. Okay? So 40 minus 24 is 16. And then EF and GT are split up even. So divided by 2, and it gives me 8. So I've got 8 and 8. Okay? So whichever right triangle you want to look at now I have one leg in the hypotenuse. I've got 2 of the 3 sides, so I could just use the Pythagorean formula. So I'm going to say that's B again, these look longer. The number's actually going to be shorter, but it's just the way I drew it. If you look here, LF and AG look shorter than FE and GT. But anyway, all right, so this is B. Okay, so I've got, this is going to be A, this is going to be C, so I've got 8 squared plus B squared equals 10 squared. I know my 2's aren't really showing up. So I got 64 plus B squared equals 100. I subtract 64 from both sides. B squared equals 36. Square root both sides. B would be 6. There we go. And that is, and so we wanted LF. So I was saying the triangles didn't matter. It does want LF, but LF and AG would be the same thing, which is 6, which is answer choice 1. All right, so there's the first page, and I'll be back later this week with pages 2 through 4. Until then, y'all keep working.